Okay, guys, so this is the last section, and then we're done. 5.6. So let's see. Okay, so this is talking about the Hinge theorem. We went over the Hinge theorem a lot last class. So remember that your Hinge theorem is dependent on you having two congruent corresponding sides and then one included angle that is not congruent. Why does it have to be not congruent? Because we want to make sure that that third side of the triangle that we don't know is gonna be a different length. Because if it was just the same length, if the angle included was the same as the other angle that's included, if they were congruent, then we would just have congruent triangles, and there's no point in using the Hinge theorem. The Hinge theorem allows us to see that the smaller an angle is, the bigger the opposite side is, the longer the opposite side is. The smaller the angle is, the shorter the opposite side is. So that's for the Hinge theorem. So for the Hinge theorem, you want to take a look at, for the Hinge theorem and for the converse Hinge theorem, you're going to have two congruent corresponding sides for sure. That's a given. Now, depending on if you have your included angle given, your included angles given to you, that's going to mean you're going to use your Hinge theorem, your SAS, inequality theorem. Now, if you have your third side known, your third congruent corresponding side known, but it's obviously it can't be congruent, then you're going to use your converse Hinge theorem or the SSS inequality to find that missing included angle based on the side length of that third side of those two triangles. So we'll see what that means right now. So using the Hinge theorem, its converse or a congruence postulate or theorem, fill in the blank. Okay, so I have here, what do I have here? Okay, so I have here, I have two congruent corresponding sides. I have one congruent corresponding side there. I have one pair of congruent corresponding sides, two pairs of congruent corresponding sides, and then I know that this is a reflexive property, right? So what do I know about these two triangles? They're what? They're congruent based on the SSS postulate. So what do I know about 1 and 2? They're equal, okay? So now, excuse me, let's go here. So I have two pairs of congruent corresponding sides. What about my included angle? Are they different? Yes. So that means this third side, this RT, and this VN are going to be different side lengths. They're going to be different length. Which one's going to be longer, the RT or the VN? It's going to be the RT because the opposite side, because the opposite angle, the included angle, is bigger than this included angle. Okay? So RT will be greater than. Okay, let's go over here. So I have here, what do I have? I have one pair of congruent corresponding sides, and I also have another pair of congruent corresponding sides right here because of the reflexive property of congruence. So now I have two pairs of congruent corresponding sides. Do I have an angle? I don't have any angles. So I can't use my Hinge theorem, but I do have what? The third side. So I'm going to use my converse Hinge theorem to gather information about what is the opposite angle to this side length AB? Angle BCA, this one. And what is the angle opposite to the 17? It's the angle CAD, this one. So now, what do I know? Which one's bigger and which one's smaller? Well, the 2 is going to be bigger, the bigger angle, because it's opposite to the longer third side. Okay, so 2, so it's going to be measure of angle 1 is less than measure of angle 2. Now, so here I have one pair of congruent corresponding sides, and I also have my reflexive property of congruency telling me that AC is congruent, to AC. So now I have two pairs of corresponding congruent sides, and I have an included angle, right? This angle is included between these two and between these two, right? So which side length is longer? Is it AB or is it AD? It's AD because 27 is greater than 24. So AD, or AB is less than AD, whichever. Okay. Now, I have here a couple givens. I have that n is the midpoint, cool. So n is the midpoint, so kn is congruent to mn, okay. I also have that ln is congruent to ln because it reflects a property. And a lot of people would just give up and be like, well, mister, you know, there's no third side angle, there's no third side measurement, and there's no other angle, there's just one angle. You said we need at least two of the third side or two of the included angle. But I don't have this one, so I'm done. So a lot of people would pick no conclusion. And that's not true, because the same way that we inferred that ln is congruent to ln, and the same way that we inferred that this AC is congruent to this AC, all those inferences that we made, we can also make the same here to tell us what this angle is. This angle, if we use the linear pair theorem, it would just be 180 minus 78 would give us this side, which is what, 102. So now which side is longer? KL or LN or LM? It's KL. So you're going to pick LM is less than KL. Okay? Now, and which theorem did I use for this one? I used the Hinge theorem, right? SAS. SAS. Okay? So now let's take a look at this one. Okay, so I actually have two pairs of congruent corresponding sides right here. I'll put a different color because too much blue going on in here. So side, 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 side. Now, I have included angles, but do I actually have included angles? I have one here, but this one, it doesn't have a finite measurement, so I can't use the SAS to find out anything about these sides. But what do I have? I do have a value for the third side of each triangle. So I have to use the SSS inequality theorem, right? Or the converse Hinge theorem to tell me that which angle is bigger. Which angle is bigger? This one or this one? This one is going to be bigger. Why? Because it's opposite to the bigger side length. 6 is greater than 5. So that means no matter what the x is for this answer, this degree could never be bigger than this degree. Okay? So now let's see what they want me to answer. So the range, okay, so find the range of possible values for y. So look, they already wrote it down how I like to write it down. Less than x, less than the signs. Okay? So now they want us to have a lower limit and an upper limit. Okay, so let's find out what that is. So what is the biggest that this angle could be? The biggest. Well, the biggest, not including that answer. The biggest this could be, not including that actual number that we give, is 31. So it has to be something less than 81, right? So if this angle cannot be any greater than 31, I have to say that x minus 7 is less than 31. So plus 7. So my x has to be less than 38. And look at that. That goes perfectly in line right here. This is perfectly placed right here. So I'm going to put 38. Now, in purple, I guess. Red. So in red, let's draw. So we have the upper limit of what x could be. What about the lower limit? What is the lowest degree that this angle could be, not including that actual degree? Well, 0. There's no such thing as a 0 degree. So I'm going to do x minus 7 is greater than 0. Plus 7 plus 7. So x is greater than 7. So this does not look like the nice format I want to put here. This is a less than sign. This is a greater than. So all I'm going to do is just switch it. So I'm going to flip it so that it's 7. 7 is less than 8. So now I have my two less than signs that I wanted, right? So now I'm going to put a 7 right on here. And it makes sense because look, if I put this range onto here, what is 7 minus 7? 0. Can this be 0? No. So it's anything above that. So I could do 7.1. So what is 7.1 minus 7? It's 0.1. Can 0.1 be an actual degree? Yeah, it could. It's probably not going to because that's such a tiny, tiny, tiny angle, but it is possible, and that's what they want, a range. Okay? So we just have 2 more questions, and then we're done. So, which of the following correctly explains why the figure cannot have the labeled dimensions? Okay, well, I already see something wrong. How can this side length be lesser than this one when its opposite side is greater than this one? That doesn't make sense to me. This would have to be greater. This would have to be greater in order to make this make sense. Or this would have to be smaller for it to make sense. So, which of the following correctly explains why the figure cannot have the labeled dimensions? The longer third side is opposite the smaller included angle. Yeah, that doesn't make sense. Oh, by the way, you see how we're using the Hinge theorem? Because of this. We're looking at the Hinge theorem to prove this. How this is not possible. Okay, so A is correct. The shorter third side is opposite the smaller. No, that would actually be correct. The longer third side is opposite the larger. That would actually be correct. And none of the explanations are, no, that's nothing. So now, how can the dimensions be changed to make the figure possible? Okay, so let's look at A. Increase the length of the side opposite the larger angle. Didn't we say that? Didn't we say that if this length was bigger, then it would make more sense because then this would be valid? Yeah. So increase the length of the side opposite the larger angle so that it is longer than the side opposite the smaller angle. That makes sense. Or we can do what? Decrease the length of the side opposite the smaller one to make this one smaller so that it's shorter than the side opposite the larger to make sure that it's smaller than this one. Yeah. What if we decrease the length of the side labeled 17? This one. So we know this and this is true. Well, if I decrease the length of this 17, that's going to make my answer even more looking crazy. So that one's no. Decrease the measure of the angle 98. No, if I decreased it, it still wouldn't be valid because how can 18 be a smaller angle than 17 to this big 101, to this big one? So no. Increase the length of the side labeled 18. Even if I increase this, it'd still be wrong because how is there a bigger side length to a smaller angle than this one? That doesn't make sense. Increase the measure of 101. Even if I were to increase this to, like, let's say 103, this would still not make sense. That how is this smaller degree opposite to the smaller side? So no. And then the last one, switch the labels of the two sides labeled 17 and 18. Yeah, so they're pretty much saying if I got rid of this and I put 18 here and then I got rid of this and I put 17 here, then it would make sense, which it would, because then the smaller angle would be opposite the smaller side and the bigger angle would be opposite the bigger side. So yeah, so that's why that's the answer. Now, last one. So I'm going to use my calculator for this one. Okay, so what do I notice I have here? I have a bunch of triangles. Specifically, what type of triangles do you guys see here? What type of triangles? I see isosceles triangles, right? Because I have two congruent sides opposite of what? Base angles, right? So what do I know? If this is 74, what do you think this angle has to be? 74 as well. 74. So once again, look here. Angle, side, opposite, opposite. Well, what do I know about if this is 65, what does this have to be? 65. This has to be 66. This has to be 68. And this has to be 67. So now, what is the only angle left I have to find? The included ones. These included ones. This one, this one, this one, this one, this one. So let's do that. So what is 180 minus 74, or 74 plus 74 equals, plus this equals 180. So I'm going to just do 180 minus 74 minus 74, which will give me 32. So I know this is 32. Okay, let's look at the other one. 180 minus 65 minus 65 is 50. Okay, 180 minus 66 minus 66 is 48. 44. I'm just doing the triangle angle sum theorem, guys. I'm not doing anything crazy. Oh, whoa. I already know somebody was flipping. I'm like, oh my god, you're wrong. You're so wrong. Going straight to the comments. 67. Okay, 180 minus 67 minus 67, 46. Okay, cool. So now, can I make inferences about what the length of AB, BC, CD, DE, and EF are going to be? Yeah, I can now figure out which is going to be greater. This side, this side, this side, I can find out which side is going to be greater because now I have an included angle, and that's going to tell me which of these side lengths is the longest and the smallest and all that stuff. So what is my biggest side length? Let's do it in purple. So my biggest side length is BC. My second biggest is CD. Third is EF. Fourth is this one. And fifth is this one. So what do they want us to do? From least to greatest. Okay, so my first one has to be AB. So this is gone. Okay. My second smallest, I guess. So my first one, my least is 5. What's my second least? DE. Notice how I'm crossing it off like as I go. EF. Okay. 5, 4, 3, 2. So it'd be CD. Okay. It's not this one. This is BC. So it's D. So my answer is D. And that's it, guys. So, you know, I hope this was helpful. I know I went a little bit faster on the 5.4, 5.5, 5.6. I feel like it's just because we've already done it. So I guess, I don't know. I guess I just feel that we didn't have to go that into it. But once again, if you guys leave comments on the videos, I will try to respond. And if I get a lot of people asking the same comments about the same questions, I'll make a YouTube short and I'll address it like within like a minute. I'll try to do something like that. So yeah, don't worry about the My Math Labs. I mean not the My Math Labs. Don't worry about the iExcel. I know people were talking about that. We'll figure that out in due time. Just please make sure that we're studying. Look at the PowerPoints. Look at your My Math Lab. Do practice problems. Look at my videos. Look at other videos. Read the book. Whatever you guys need to, you know, feel prepared for the exam. Okay. We'll do a 30-minute review before the exam, of course. And good luck, guys. I hope this helped. So have a fun vacation, but make sure you're all